Hey everyone, and welcome back. Today we're going to do a deep dive into somewhere that's pretty close to home, all things considered, but still pretty mysterious. The far side of the moon. It's kind of wild how something we can see almost every single night still has so many secrets, right?
Yeah, it's true. We think of the moon as this familiar thing in the sky,
Yeah.
right? But half of it's been hidden from us for almost all of human history.
Right, exactly. And I'll admit, I used to think the whole dark side thing was real, like it was in permanent shadow or something. I didn't learn about synchronous rotation till later on, that whole gravitational dance that keeps one side facing us all the time. The dark side myth. It's important to remember that both sides of the moon get the same amount of sunlight. The difference is all about perspective. Like imagine spinning a basketball on your finger, and there's a little sticker on one side. You'll only ever see the sticker side, right? Even though the other side is getting just as much light.
Okay, yeah, that makes sense. But it's still kind of crazy that there's this whole other side of the moon that no one saw for centuries. What do you think people thought before we had pictures of it?
For centuries, the far side was basically just a blank slate for people to imagine things.
Yeah.
Some people thought it was just a mirror image of the near side. Some people thought it was full of crazy landscapes and alien civilizations. It wasn't until 1959 when the Soviet Luna 3 spacecraft flew around the moon that we got our first real look.
And those first pictures must have been a shock, right? Because on the near side, we've got those smooth, dark Maria from the volcanic eruptions a long time ago. Did they find more of that on the far side?
Nope, not at all. It was a totally different landscape. Instead of those smooth plains, Luna 3 sent back pictures of all these craters and rough terrain. It was like comparing a brand new parking lot to a mountain range that's been around for millions of years.
Wow, yeah. That's a huge difference. It makes you wonder how two sides of the same thing could end up looking so different. They're both orbiting the same planet, getting hit by the same space stuff, so what gives...
Well, it all goes back to how the moon formed and its relationship with the Earth. Imagine the moon, billions of years ago, still molten and way closer to the Earth than it is now.
Okay, so molten moon close to the Earth. Got it. What's next?
Well, being that close to the Earth meant that there were some seriously strong tidal forces going on, like a huge cosmic tug of war. And those forces really messed with the moon's molten surface,
Yeah.
especially the side facing Earth.
So the near side was getting pulled and stretched by Earth's gravity. I'm guessing that wasn't great for its looks?
Exactly. The near side's crust got stretched and thinned out. So molten stuff from inside the moon could rise up and erupt through these volcanic vents. And that created those huge lava flows that eventually hardened into the Maria we see today.
But the far side being farther away from Earth's gravity didn't get that stretching and volcanic makeover.
Right. The far side's crust stayed thicker and didn't have as much volcanic activity. And without those lava flows to fill things in the far side, was basically a sitting duck for impact craters. It's like a record of billions of years of stuff hitting it.
So in a way, the far side is like a time capsule showing us what the early moon, maybe even the early Earth looked like before volcanoes changed everything.
Yeah, it's a window into the past.
Yeah.
It gives us clues about the early solar system and how planets and moons get their surfaces. But it's not just about the past. The far side is also super important for future scientific exploration.
Oh, okay, now I'm really interested. So we've got this ancient cratered surface that's like a time machine. What makes it such a good place for science in the future?
But well, think about this. Humans are really noisy when it comes to the electromagnetic spectrum. All our radio signals, all our communication, all our tech. It creates this kind of radio smog around the planet. That makes it really hard for astronomers to study the faint signals coming from deep space.
So we're drowning out the whispers of the universe with our own chatter, basically.
Yeah, I could see how that would be a problem.
It's a huge problem. But the far side of the moon is like a solution because it's always facing away from Earth. It's like this giant shield blocking out all that radio noise. It's like radio silence, the best you'll find anywhere in the solar system. So it's like a cosmic quiet zone where astronomers can actually hear those faint whispers from the universe.
Exactly. It's a dream come true for radio astronomers. In that environment, they could maybe even detect signals from the very early universe. Signals that have been traveling for billions of years, telling us about how the first stars and galaxies formed.
That's amazing. We're talking about hearing echoes of the Big Bang, right? That's the kind of stuff that changes everything we know. But how do we even get equipment to the far side to do all that? It's not like we can just pop over for the weekend.
Landing on the far side is really tough. You need some serious technology and perfect navigation. But it's possible. China did it back in 2019 with their Change 4 mission.
Oh, that's right. I remember that. And they didn't just land, they sent a rover too, right?
They did. The U-22 rover is still working today collecting data about the moon's surface, what it's made of, and its history. It's been going strong for a while now, which is pretty impressive.
So the U-22 rover is our eyes and ears on the far side. What kind of stuff has it been sending back? What's it like over there?
Well, one of the coolest things they've found is something scientists thought might be there, but never actually confirmed until the rover got there.
Okay, I'm listening. What did they find?
U-22 found evidence of stuff that came from deep inside the moon's mantle, just lying around on the surface.
Wait a minute. Stuff from the moon's insides is just on the surface. How'd that happen? That's not something you see on the near side, is it?
Nope, not really. This discovery is all about one of the most interesting things on the far side, the South Pole Aitken Basin. It's this huge impact crater, one of the biggest and oldest ones in the whole solar system.
Okay, so we're talking about a crater so big that it blasted stuff from the moon's insides out onto the surface. That's a huge impact. I can't even imagine. Just how big are we talking?
It's over 2,500 kilometers across and up to 13 kilometers deep. If you were standing in the middle of it, you wouldn't even be able to see the edge.
Wow, that's just massive. I can see why scientists are so interested in it. But wouldn't studying a crater that old be like trying to read a book with half the pages ripped out? How much can we actually learn from something that old?
That's true. It is hard to figure out what happened billions of years ago. But the South Pole Aitken Basin still gives us a chance to peek into the moon's distant past, maybe even back to when the solar system was still forming.
So it's like a giant window into the moon's early history. But how can scientists actually use it to learn about the moon's insides and how it evolved?
Well, the impact that created the South Pole Aitken Basin was so powerful, it basically dug out a bunch of material from the moon's mantle and brought it up to the surface. It's like a giant drilling project, except nature did the drilling for us.
So it's like a giant scoop that revealed stuff that would normally be hidden way down deep. Pretty convenient for the scientists. What kind of info can they get from that mantle material?
By looking at what that material is made of, they can learn about what's inside the moon, the temperatures and pressures that were deep down there, and even how the moon itself formed. It's like a treasure chest of information.
Okay, now I see why this crater is such a big deal for science. But you mentioned earlier that there were other mysteries on the far side, too. What else has got scientists excited?
One of the most exciting things is the possibility of water ice hidden in those craters near the poles that are always in shadow.
Hold on, water ice on the moon? I thought the moon was totally dry. I mean, all the pictures we see are just dust and rocks. How could ice survive there, especially without any air?
It's all about location and some cosmic geometry. Those craters are near the moon's poles where the sun never gets high enough to shine inside. They've been in shadow for billions of years, so it's super cold down there, like negative 250 degrees Celsius or even colder.
Well, colder than Antarctica by a long shot, but how did the ice get there in the first place? And how's it lasted so long?
Scientists think it probably came from comets and asteroids that hit the moon a long time ago. And because those craters are always in shadow, there's no sunlight to melt the ice or make it evaporate. It's basically been frozen in time since the early solar system.
That's amazing, but finding water ice on the moon, that's got to be more than just a cool scientific fact, right? It seems like it would be a huge deal for future missions to the moon. I mean, we need water for pretty much everything.
You're right. Finding water ice on the moon would be a total game changer. Not only do we need water to survive, we can also break it down into hydrogen and oxygen, which we can use for rocket fuel.
So we're not just talking about drinking water. We're talking about fuel for rockets and longer missions. That would change everything. But before we get ahead of ourselves, how do we even know for sure that there's ice down there? Has anyone actually confirmed it?
That's the big question. There's a lot of evidence from orbit and remote sensing, but we need to actually get down there to be sure. We need to get boots on the ground, or at least rover wheels on the ground, to see how much ice there is and if we can actually use it.
So the mystery continues. Sounds like there's a lot more to explore on the far side of the moon, from ancient craters to maybe even water ice. But we'll have to save the rest of this adventure for part 2 of our deep dive. Stay tuned.
You know, it's amazing how the far side of the moon has gone from this like blank spot on the map to this place that's just buzzing with possibilities. It seems like every day there's a new discovery or some ambitious plan to explore it.
It really does feel like we're watching a whole new frontier open up right in front of us. We've talked about all the scientific stuff waiting to be discovered over there, but what about the practical side of things? What does the future hold for humans actually exploring and maybe even living on the far side?
Well, if you're looking for ambitious plans, look no further than NASA's Artemis program. This isn't just about sending astronauts back to the moon for a quick visit and a photo op. It's about establishing a long-term human presence on the moon, that can actually last.
Artemis is the one with the plan to build a base camp on the moon, right? I remember hearing about that. But where does the far side fit into all of this?
The far side is actually a perfect spot for future lunar bases and scientific outposts. We've already talked about how great the radio silence is for science, but there are other things that make it appealing for actually living there, too.
Okay, I'm all ears. What else makes the far side a good place to set up shop?
Well, one big advantage is that the far side is relatively untouched compared to the near side. The near side has seen a lot of human activity over the years. This means there's a better chance of finding pristine resources on the far side, including those water ice deposits we were talking about.
So it's like finding a piece of land that's never been developed. More resources to go around. That makes sense. But wouldn't being on the far side make it harder to communicate with Earth? I mean, we're talking about being on the opposite side of the moon. Wouldn't that cause a communication blackout?
That's a good point. You're right, direct communication with Earth wouldn't be possible from the far side. But there are solutions in the works. NASA is looking into putting relay satellites in orbit around the moon. That way we could have continuous communication between the far side and Earth.
So kind of like bouncing a signal off a satellite to get around the moon being in the way. Clever. Okay, so we can communicate. We've got potential resources. But what about the environment itself? Is it even a place where humans could spend a lot of time?
Well, the moon is a pretty harsh environment. No air, extreme temperatures, and you're constantly getting bombarded with radiation.
Mm.
But those are challenges we can overcome with the right technology and planning.
I guess that's what makes it an adventure, right? But wouldn't it be a little isolating to be so far from Earth with only a few other people? I mean, even the astronauts on the International Space Station are closer to home.
That's a question that psychologists and mission planners are thinking about a lot. We're still studying how being on long missions to the far side would affect people psychologically, but, there might be a silver lining to that isolation. Think about it being shielded from all the noise from Earth. Not just radio waves, but also the news, the constant demands of modern life. It might be incredibly peaceful and a really good environment for focusing on scientific work.
I can see that. No distractions from Earth, just you small team and the vastness of space. It would definitely be a unique experience, almost like a lunar monastery. But let's be realistic for a second. This isn't just about science and exploration, it's about economics too, right? What's the financial reason for setting up shop on the far side?
You're hitting on a key point there.
Mm.
People are starting to realize that the moon, especially the far side, could be really valuable economically. We've talked about water ice, which would be a vital resource for a lunar base, but we could also mine other things like helium-3.
Helium-3, what's that?
Helium-3 is this rare type of helium that scientists think is pretty abundant on the moon. It could be used as fuel for fusion reactors, which could provide clean energy here on Earth pretty much forever.
Okay, so now we're not just talking about lunar bases, we're talking about lunar mining operations. Sounds like something out of a sci-fi movie. But isn't this starting to sound a little bit like a lunar gold rush? Are we just going to go up there and start taking everything from the moon for ourselves?
That's a big debate in the space community right now. It's important to be careful and sustainable when it comes to taking resources from the moon. We don't want to make the same mistakes we made here on Earth.
Absolutely. We need to learn from our past and make sure that anything we do on the moon is done responsibly and without harming the environment. But with all this talk about bases and resources and mining, it's easy to forget that the moon is more than just a place to take stuff from. It's been a source of wonder and inspiration for humans for as long as we've been around. What does the far side, with all its mystery and hidden features, add to that?
You're right, the moon has always had a special place in our minds and hearts. And the far side, with its unexplored landscapes and unique features, just makes it even more fascinating. It's a symbol of the unknown, a place where anything is possible.
It's like looking at a blank page in a storybook. Your mind just starts racing with possibilities. It makes me think about all the science fiction stories that have been inspired by the moon. From Jules Verne's From the Earth to the Moon to Arthur C. Clarke's 2001, A Space Odyssey. The moon has been the setting for some of the most imaginative and thought-provoking stories ever told.
And the far side, with all its mystery, takes that inspiration to another level. It's a blank canvas for our imaginations, a place where we can explore what humans are capable of, the challenges of space travel, and what it means to encounter the unknown.
It's interesting, though, that most sci-fi stories set on the moon focus on the near side, the side we're familiar with. I wonder why that is.
I think it's because for a long time the far side really was unknown. It was this blank slate where anything could happen. But now that we have pictures and data from the far side, it's becoming a more realistic setting for stories. It's a place where writers and filmmakers can base their narratives on a reality that's even more amazing than anything we could have imagined.
So the far side is becoming less of a mystery and more of a real place, a real world with its own landscapes and features. That opens up a whole new world of possibilities for storytelling. I'm excited to see how sci-fi writers and filmmakers use the far side in their stories in the future.
Me too. And I think one of the coolest things about the far side is how it challenges our ideas about what's normal in space. We tend to think of the side of the moon we see all the time as the standard. But actually, the far side is more typical of what planets and moons look like throughout the solar system.
So you're saying that our moon, the one we're so used to seeing, is actually kind of unique, that most planets and moons haven't had their surfaces smoothed out by volcanoes like the near side of our moon.
Exactly. All those craters and rough terrain on the far side, that's more like what we see on other celestial bodies like Mercury or the moons of Jupiter and Saturn.
That's pretty mind-blowing. The moon we see every night, the one that's inspired so many people for so long, is actually kind of an oddball. And it makes me wonder if the far side is more like other planets and moons. What does that mean for the possibility of life out there? We're always looking for planets that are like Earth, but maybe we should be looking for places that are more like the far side of the moon.
That's a great point. For a long time, we thought that life could only exist in places that were a lot like Earth. But then we discovered extremophiles, these organisms that can survive in really extreme environments here on Earth, like deep sea vents and hot springs. That changed everything.
So life is tougher and more adaptable than we thought.
Exactly. And if life can exist in those extreme places here on Earth, why couldn't it exist in the shadowed craters on the far side of the moon, or in similar places on other planets and moons?
That's a really exciting thought. Maybe we shouldn't limit our search for aliens to planets that look like Earth. Maybe we should be looking in places that we thought were too harsh or too different. The far side of the moon could be a good place to start.
It's definitely worth exploring. And the great thing about exploration is that it always challenges what we think we know and expands our horizons. The far side of the moon is a perfect example of that. It's a place that used to seem completely alien and impossible to reach, and now it's calling out to us with the promise of scientific discoveries, future settlements, and maybe even clues about whether there's life beyond Earth.
It's a frontier that's full of potential, both for making our lives better and for understanding our place in the universe. But before we get too carried away thinking about the future, let's take a closer look at the missions and technology that are making this new era of lunar exploration possible, especially on the far side. We'll dive into that exciting world in part 3 of our deep dives. Stay with us.
All right, welcome back to our lunar adventure. We've been all over the far side of the moon, discovering its hidden landscapes, its scientific secrets, and how it could change our future in space.
And now it's time to talk about the how. What are the actual missions and technology that are making this new era of lunar exploration possible, especially on the far side? Exactly. It's great to talk about lunar bases and scientific outposts, but how do we actually get there? What kind of engineering are we talking about?
So first off, there's NASA's Artemis program, which we've mentioned a few times already. It's a huge project that's really pushing the limits of space exploration in a lot of ways.
Right. I remember the main goal of Artemis is to have a sustainable human presence on the moon. But how are they going to actually do that? What are the main parts of this program?
It all starts with getting there. And for that, NASA is building the Space Launch System, or SLS, which is going to be the most powerful rocket ever built.
The SLS, that's the one that's supposed to be even more powerful than the Saturn V rocket that launched the Apollo missions, right? Talk about a giant leap forward. What's the advantage of having such a powerful rocket?
The SLS is designed to carry astronauts and cargo to the moon all in one launch, along with the Orion spacecraft, which is the crew capsule for deep space missions. This means we can send bigger payloads, more equipment, and basically have a stronger presence on the moon.
So it's not just about getting there, it's about having the ability to build something substantial once we're there. That makes sense. But what happens once they get to the moon? Where do they set up camp?
That's where the Lunar Gateway comes in. It's a space station that will orbit the moon and act as a central hub for all our lunar operations.
Okay, I've heard of the Gateway, but I'm still not quite sure what it is or why it's so important. Can you explain it a bit more?
Picture a small space station, but instead of orbiting Earth, it's orbiting the moon. That's basically the Lunar Gateway. It's designed to be a multi-purpose facility, a place to stage lunar landings, a lab for science experiments, a docking port for spacecraft, and a platform for testing out technologies for deep space missions. like going to Mars.
So it's like a lunar base camp in orbit.
Exactly. And the really cool thing about the Gateway is that its orbit will allow it to access both the near side and the far side of the moon.
So it's in a perfect spot to support missions all over the moon, including the far side. That makes a lot of sense. But how do astronauts actually get down to the surface from the Gateway? They can't just hop in a rover and drive down, can they?
That's where lunar landers come in. NASA is working with commercial partners to develop a new generation of landers that can safely transport astronauts and cargo back and forth between the lunar surface and the Gateway.
So it's a team effort with both government and private companies working together. That's interesting.
It is. This partnership model is becoming more and more common in space exploration. It allows NASA to take advantage of the innovation and efficiency of private companies while also helping to grow a stronger, more competitive space industry.
It's great to see this kind of collaboration happening. It feels like a real global effort to push the boundaries of what's possible in space. But it's not just about getting to the moon, it's about staying there. What kind of habitats are we talking about for a long-term lunar presence, especially on the far side?
That's one of those exciting areas of development right now. Scientists and engineers are exploring all sorts of ideas, from inflatable modules that can be set up on the surface to habitats that can be 3D printed using lunar regolith, the loose, dusty material that covers the moon.
Wait a minute, 3D printing habitats from moon dust? That sounds like something straight out of science fiction. How does that even work?
It's a pretty amazing technology. You use a robotic system to melt and fuse lunar regolith layer by layer to build solid structures. It's still in the early stages, but it could completely change how we build things on the moon. We could build habitats and other structures using materials that are already there.
That would be a huge game changer for logistics and sustainability. No need to ship heavy building materials all the way from Earth. But what about the challenges of actually living on the far side? We talked about the communication issues, but what about things like generating power, shielding ourselves from radiation, and even the basics like air and water?
Those are all critical things to consider. We could generate power using a combination of solar panels and maybe even nuclear reactors. For radiation shielding, we could design habitats with protective barriers made from lunar regolith or other materials. And for air and water, we could extract them from resources on the moon, including water ice, if those deposits turn out to be as large and accessible as we hope.
So it's a multi-pronged approach using a variety of technologies and resources to create a self-sustaining outpost on the moon. It sounds incredibly complex, but also incredibly exciting. It feels like we're on the cusp of a new era of human exploration where we're not just visiting other worlds, but learning to live on them.
It really is a transformative time in human history. And the far side of the moon, with all its challenges and potential, is playing a key role in this incredible adventure.
It's been an amazing journey exploring the mysteries of the far side. From debunking ancient myths to uncovering its geological secrets, from the promise of groundbreaking science to the challenges of living there. The far side has captured our imaginations and pushed us to reach for what seems impossible.
It reminds us that exploration is at the very core of being human. That desire to venture into the unknown, to learn new things and expand our horizons, is what has driven us forward throughout history. And the far side of the moon, with all its hidden wonders and untold stories, is calling us to continue that journey of discovery.
Well said. And as we continue to unlock the secrets of the far side, who knows what we'll find? What new discoveries await us? What unexpected wonders will we uncover? It's a journey filled with excitement, challenges, and the promise of incredible rewards.
I couldn't agree more. The far side of the moon is a frontier full of potential for both practical advancements and expanding our understanding of our place in the universe. It's a place that invites us to explore, to dream, and to push the boundaries of what's possible.
And who knows, maybe one day we'll be recording a deep dive from a lunar base on the far side of the moon.
Yeah, that would be an episode for the history books. Until then, keep looking up, keep exploring, and never stop asking questions. The universe is full of wonders just waiting to be discovered.
Well, that's all for our deep dive into the mysteries of the moon's far side. We hope you enjoyed the journey with us. Until next time, keep exploring.